Welcome to Subnetting Level 3, Decimal to Binary Conversions. In this video, we're going to learn how to take a decimal number and represent it as its binary equivalent. To show you the process, we're going to start with the decimal number 17, and we want to write it in its binary format. So what we're going to do is we're going to take a little area over here at the screen, and we're just going to write the 17 there as a starting point. And then we're going to go look at the binary placeholders. So in this case, we're going to start with the largest one. So the value of 128. So 128 is too big for 17. So we're just going to say, well, that placeholder then is going to be represented with the bit 0. We go on, 64 is too large, so that's also a 0. 32 is bigger than 17, so that's going to be a 0. And then we get to 16. 16 actually can go into that number. It's less than 17. So we're going to put a 1 there, and then we're going to subtract 16 from 17, leaving us with the remainder of 1. Now we're going to come back to the placeholders, and then our next one is an 8. So an 8 is bigger than 1, so that's going to be a 0. A 4 is bigger than 1, that will be a 0. Also 2 is larger than 1, that will be a 0. And then our, obviously 1 fits into there, so we'll put a 1 above that 1, and we'll subtract it. When you get to the result of a 0, you're done. You can always go back and double check, like, is this binary? The answer is at the bottom of the screen, 0001, 0001. And you can go back and do a kind of a self check because you look for the ones. So there's a 1 there, 16 plus 1 is 17. So indeed, that is the binary equivalent to the decimal number 17. All right, let's do another one. Write the decimal number 78 in its binary format. So once again, we're going to start up here with the 78. 128 is too big, so that becomes a 0. 64 will go in. That's less than 78. So I'm going to put a 1 there, reminding myself that I'm going to subtract 64 from 78. The result is a 14. So once I do the subtraction, I go back to where I left off. 32 is too large. 16, too large, so I mark that with a 0. 8 is less than 14. It can be subtracted from that. So I'm going to go ahead and subtract 8 from 14. And I'm going to be sure to put a 1 in that placeholder so I know that I've taken 8 as part of that value. I'll subtract it from the 14 and get the remainder of 6 and then continue on. 4 is actually can go into that number. So I'm going to actually take a 4. I'll put a 1 where that is, and I'll subtract 4. Now that leaves me with 2, and then my next my next placeholder is 2, which is a perfect match. So I'll put a 1 there. That gives me a -2, which means I've got a 0 there, which means I'm basically done. So that last digit will be a 0. Once again, what's remaining on my screen is the answer. So 78 would be 01, 00, 1110. That's how we would write the number 78 in binary. Once again, you can double check that by just doing a little math kind of backwards. So you'd have 64 plus 8 plus 4 plus 2. And you could see that indeed that is 78. All right, our last example here, write the number 203 in a binary format. So we're going to start with 203. Up here, as we normally do, we see that 128 will actually fit into there. So we're going to put a 1 there, and we're going to subtract 128. The result is 75. So I can use 64. So I'm going to put a 1 in the placeholder, and I'm going to subtract 64. That gives me a remainder of 11. So then I look at that 11 and I continue on. 32 is too big, so that's a 0. 16 is too big, that's a 0. 8 will fit into 11. So I'm going to put a 1 there, and I'm going to subtract 8 from 11 and get 3. Then I come back and 4 is too large. 4 is larger than 3, so that's going to be a 0. 2 is smaller than 3. It's less than 3, so I can subtract that. So I'll put a 1 in the placeholder, and then I'll subtract it from the 3. That leaves a 1. Perfect match. I'll put a 1 in the last placeholder, subtract that, and I'm done. So what's remaining on the screen is the binary equivalent to the decimal number 203. Once again, you can double check by adding all the places where there's a 1, 128 plus 64 plus 8 plus 2 plus 1 is 203. Remember, when we're dealing with decimal numbers, that the smallest number we can have for an 8-bit binary number would be 0, meaning all places, all 8 bits would be 0, and the largest number would be 255, where all 8 bits would be 1s. All right, time for you to practice. Remember, no calculators, just grab a scratch piece of paper, and here are your decimal numbers, and I want you to write this as an 8-bit binary number. If you'd like, you could pause the video, and when you come back, I will have the answers revealed. So let's take a look at 12. The answer for 12 is 0000110, which makes sense because you have an 8 and a 4, and that would give you 12. Right? If I put all of those placeholders up here, I would have a 1, a 2, 4, 8, 16, 32, 64, and 128. That's just a good recheck after you get your answer to make sure you've got the correct binary equivalent. All right, 224, your answer should be 111, 00000. So 3 ones followed by 5 zeros. 47 is 001, 01, 111. And 183 is going to be 101, 101, 11. All right, I hope that went well for you. You are completely done with level 3, and you can move on to level 4.